diamond went so quickly, but we did see a diamond ring at the very beginning there. Can you describe to us what is that?
Sure, that diamond ring effect is due to the moon not being perfectly smooth. It's got mountains, it's got valleys. So just like here on Earth when we see a sunrise or a sunset through a valley, we just watched a sunset through a valley on the moon.
Absolutely stunning.
Oh my.
So you said we could see one planet. I see it right there in the sky. Can we see any others as we're looking up?
Yeah, we've got Venus on the over to one side. We've got Jupiter up here to the left of the sun. And there's the corona.
Absolutely beautiful.
That is spectacular.
Now, you also said that this is happening during what we're calling a solar maximum. Now, Patrick, does that mean that the sun is stronger right now than normal?
Not so much stronger, just more dynamic. It's changing a lot. During solar maximum, the magnetic field on the sun is more chaotic, it's more disorganized. So you see more random directions for the jets of gas leaving the sun.
Right.
That is spectacular. We could see a stream.
All right, we are reaching that halfway mark already, 2 minutes into totality.
There's even just a hint of a diamond ring down at the bottom.
I can see it. Yeah, we're looking at a diamond ring from Arkansas, the Diamond State. Now, Patrick, of course, as we've been talking about it, this is part of what we are calling the heliophysics big year. You are a heliophysics extraordinaire all the way from Washington, D.C. So what does that mean?
Okay, so the heliophysics big year started out in October of last year with the annular eclipse. And of course, we take a pause here in the middle to watch this particular eclipse, but then it will end on December 24th of 2024 when Parker Solar Probe passes as close as it's ever going to get to the surface of the sun within 9 solar radii.
Oh, wow. And I'm sure that means a lot to you because you worked on Parker Solar Probe about 20 years ago during its inception. So tell us a little bit more about that.
I worked on a concept study for Parker Solar Probe back when I was a graduate student in around 2002 or so. And back then, the idea was for it to actually dive into the sun rather than orbit the sun. So it was going to be a sun dive.
Wow, that is fabulous. This must be a very full circle moment for you, right, Patrick?
This is brilliant. This is absolutely brilliant. And that diamond ring has been Wait a minute. That's pink. What we are actually seeing is down into the chromosphere now of the sun. We're seeing a little bit deeper than the corona. I believe it's because of the pinkish color. We're looking down into the chromosphere, which is the next layer of the atmosphere of the sun down.
Oh, wow.
Wow. Oh my God.
This is like nothing we have ever seen here in Arkansas and like nothing we will see for the next 2 decades, right, Patrick?
That's right. It's going to be 21 years before we see it again here. 2045.
All right, so as we are starting to exit totality, of course, we're going to be very careful with our eyes if needed. We're going to put those solar glasses back on, of course. And the crowd just erupting, falling quiet again as they watch this magnificent moment take place.
I am actually seeing bats flitting through the air.
Oh, wow. Well, we will be very careful then.
Well, yeah.
And why is that, Patrick? Again, those nocturnal animals are coming out, right?
As far as they're concerned, it's nighttime. It's time to feed. So they're coming out to feed on all the mosquitoes we've been swatting.
Okay, got it. We'll be very careful for all those nocturnal critters around us right now.
All right. We are getting closer. Get ready to put those glasses back on.
All right. We're putting those glasses back on. The crowd wow, a second diamond ring seen from right here in Arkansas, the Diamond State. Absolutely stunning.
Outstanding.
Beautiful. Patrick, we're going to turn around now and just one question I really do have to ask you before we let you go is, are you Team Sun, Moon, or Earth?
I am Team Sun. Team Sun all day long.
Fantastic. I figured from a heliophysics expert like you. We want to thank the city of Russellville for hosting us, Arkansas Tech University, and our telescope feed operator, Joe Mattis. Thank you so much. Now, let's get back to James Traley over at Kennedy Space Center. James, back to you.
Yeah, thanks so much, Jasmine. What have you guys had there? So you were just right here in Russellville. You can see that shadow has now officially moved off and is on our way to our next target, which is up here in Carbondale. Carbondale is one of those very lucky cities because back in 2017, they were right at that intersection point of the 2017 eclipse across America. They're there again this year, but the difference is they're going to have a much longer slot. In 2017, they only had 2 minutes, 40 seconds, and that's not as much as they're going to have this year, which is 4 minutes and 10 seconds in the totally eclipsed sun. A really great viewing window for to really take in this around the sun.